You know, in the world of AI, for years, the mantra has been pretty simple. Bigger is always better. We've been watching this arms race to build enormous models, all based on the idea that size equals power. But what if that's all about to change? Let's get into it. And hey, the logic kind of makes sense, right? The more parameters an AI has, you can think of them like neurons in a brain, the more complex stuff it can handle, and theoretically, the smarter it gets. This whole idea has kicked off a total gold rush for computing power, leading to these monster models with hundreds of billions, even trillions of parameters. But this is such a fascinating question. What if the real key to intelligence isn't just about having a bigger brain, but about the quality of the education it gets? I mean, what if we've been chasing the wrong thing this entire time? Okay, now look at this. This is where it gets wild. On the left, you've got this gigantic 671 billion parameter model. And on the right, a model that's almost 50 times smaller, just 14 billion parameters. And yet the little guy absolutely demolishes the giant on this complex benchmark. So how on earth is that possible? Well, the answer lies in a huge bottleneck that's been holding back a whole new class of AI. I'm talking about what we call AI agents, and the whole problem boils down to the kind of data they need to actually learn. Right, so an AI agent isn't just your standard chatbot. Nope, this is an AI that can actually interact with the digital world. It can book your flights, manage a calendar, or crunch data by using external tools and services. But here's the catch. To learn how to do all these complex, multi-step things, it needs to practice on really realistic problems. And that, right there, is where the trouble starts. So, traditionally, there are two ways to get this practice data. You can use real user data, which is awesome for realism, but, a total privacy nightmare. Plus, it often doesn't have enough of those tricky, complex scenarios. The other option is to have humans write out scenarios by hand. That's safe, but it's painfully slow, and the results are usually way too simple to be of any real use. Basically, both options kind of stink. So, to solve this data dilemma, some researchers have come up with a totally new playbook. It's a framework called AgentSkiller, and it is designed to fix this training data problem for good. And this is the part you really gotta get. AgentSkiller isn't trying to build a bigger AI brain. Instead, it's building a better AI school. It puts all of its focus on creating the perfect curriculum, this huge, complex, and super realistic library of training data for AI agents to cut their teeth on. And this quote from the researchers just nails the core problem. They say it flat out. We're not held back by the size of our models anymore. We're held back by the quality of the stuff we can teach them. That phrase, long horizon, that's the key. It means complex tasks that take multiple steps, just like in real life. Not just answering a single question, but maybe researching a topic, then summarizing what you found, and then drafting an email to share it. That's a long horizon task. Probably the coolest way to think about AgentSkiller is like a Hollywood movie studio, but for AI. First, it builds the entire virtual world and defines all the objects in it. Then, it lays out all the tools the AI can use, kind of like props on a movie set. It fills that set with realistic data and rules. Then, and this is a brilliant move, it creates crossovers, connecting different worlds together. And finally, it automatically writes thousands of unique scripts, or tasks, for the AI agent to go and perform. So, how does this AI movie studio actually work? Let's pop the hood for a second and see what kind of engineering makes all this possible. Okay, whoa. I know this looks incredibly complicated because, well, it is. This is the full 18-step pipeline. We are not going to walk through every single one of these boxes, don't worry. But I wanted you to see the insane level of detail here. This thing isn't just spitting out random text. It's a super rigorous automated system for building entire functional virtual worlds. It really all boils down to three genius design ideas. First, it uses two different AIs working together, a creative one that comes up with the big ideas, and a coding AI that handles the precise technical execution. Second, the whole thing is run like a factory assembly line with automated checkpoints, so if one part fails, it doesn't have to start over from scratch. And third, this is my favorite part, it has a built-in quality control system that automatically finds and fixes its own mistakes. And this right here is the secret sauce. Cross-domain fusion. This is how AgentSkiller creates those really complex, long-horizon tasks that are so hard to find. It can link, say, a healthcare service with a finance service to create a task like find and schedule an appointment with a specialist, and then submit the paperwork to the insurance company for reimbursement. That's the kind of complexity that mirrors real life.
So what's the end result of all this clever engineering? The system cranked out a dataset of over 11,000 unique, high-quality, multi-step training problems. That's not just a few dozen examples someone wrote by hand. It's a massive, purpose-built library for teaching AI agents how to think.
And just look at what this data is all about. We're not talking about simple stuff here. We're talking about complex, high-stakes industries like logistics, healthcare, travel, and finance, places where getting it right across multiple steps is absolutely crucial. This is basically the Ivy League curriculum for an AI. Which, of course, brings us right back to where we started. We began with this mystery, right? This tiny little model that was punching way above its weight class. Well, now that we understand this revolutionary training method, we have our answer. Let's look at that chart one more time. That 14 billion parameter AgentSkiller model wins, not because it has a bigger brain, but because it went to a much, much better school. It practiced on thousands of complex, realistic problems that the bigger models just never even saw. The numbers on this table just tell the whole story. I mean, look at that. A score of 79.1 for our little 14 billion parameter model. The 235 billion one, 58.6. And that colossal 671 billion parameter model, barely scraping by with 50.7. It's such a clear, undeniable win for high-quality data. And this is the powerful conclusion from the researchers themselves. It really is a paradigm shift. The future of creating capable AI agents might not be a race for more parameters, but a race to build the most sophisticated and realistic virtual training grounds we can imagine. So, what are the big takeaways here? First, that amazing training data can matter way more than just raw model size. Second, we now have ways to automatically create these hyper-realistic practice worlds for AI to learn in. And finally, and this is maybe the most exciting part, this means we can build smaller, cheaper, more efficient AI agents that are still incredibly powerful. This really just opens up a whole universe of possibilities, doesn't it? If we can create a virtual training ground for basically any skill, from managing a city's power grid to discovering new medicines, what's to stop these smaller, hyper-educated AIs from mastering them? The revolution might not be about building bigger brains after all, but about building better classrooms.